I built the same project 15 times, 5 different ways, 3 runs each time, same everything, same model, same spec, same input prompts. The results range from about 23,000 tokens to almost 250,000, from about 4 minutes to 30 minutes, all for the same thing. So here's what I actually did. The project, the specification that I want to build, is deliberately simple. It's a Python API with 3 endpoints, API key authentication and OpenTelemetry instrumentation for the actual API. The simplicity is the point. It isolates the variable. The only thing that is changing is the way that I'm working with the AI. Now, every experiment starts with the same prompt. Read the specification markdown, plan the project, write the plans as markdown, and then go away and build it. I delete everything that the agent creates after each run to make sure it's a clean slate. Now, if that spec seems vague to you, it is. It's deliberately so. I wanted some ambiguity for the model and the agents to work through and potentially ask me any clarifying questions. So here are the approaches. We've got what we all do at the beginning. We do plan mode and then build mode, 2 separate agents. Second is just the build mode. It's 1 agent for everything. The third, we create 5 specialized agents and I toggle between them manually. The fourth will have those same primary agents, but I'll introduce an orchestrator. So there's kind of a coordinator at the top and then 5 specialist agents that it will send the work to. And then the 5th experiment is actually changing those agents into actual real sub-agents. Same orchestrator agent, same specialist, they're just invoked as in sub-agent mode. First, I use the plan agent in OpenCode to read the specification, plan it out, then the build agent to actually implement it. On average, we're looking at about 4.5 minutes, about 26,500 tokens. Very consistent across the 3 runs, less than 5% spread across the runs. Predictable, nice, on to the second one. This is the so-called YOLO mode. We just skip the planning agent entirely. We use the build agent for absolutely everything. It still reads the spec, it still writes the plan to disk, but then it itself goes and builds the code. This time, we average about 25,000 tokens and the time has dropped from 4.5 minutes to about 4 minutes, or just over 4 minutes. So build and plan, as you'd kind of expect, uses slightly more tokens and was slightly slower, but it's nothing too dramatic. So these 2 experiments are the baseline. They're fast, they're cheap, they're consistent, and everything else that we do from here gets compared to this baseline. Now on to the interesting ones. I asked Mimo 2.5, which is the model I'm using for everything, to define 5 specialized agents: architect, security, observability, testing, and documentation. And then I manually switch between them myself. So Mimo defined all 5 as primary agents, which I'm then gonna iterate through in this order. So I'm gonna start with the plan agent, then the build agent writes the plan that the plan agent created, it writes it as markdown. Then I switch to the architect and it reviews the plan, then the security agent, then observability, then testing, then docs, and then back to build to actually implement the code. This took forever. We're averaging about 28 minutes, and I was actually sitting at the laptop waiting for things to finish. There was no, I wasn't away making a cup of tea or something, and that's why it took so long. It really did take this long for each agent to go through. The token usage was also absolutely enormous. We're up at about 195,000 tokens average. But actually, those numbers are only half the story, because the agents that we defined weren't actually doing their jobs. So for example, I hand off to the docs agent. I then ask it to review the plan according to its specialty documentation. I'm expecting it to say, well, we need code comments, or we need the readme's empty, so we need a readme, or actually this project is so complex it needs its own full doc website. And it doesn't. It starts doing a security review instead. And when I actually called this out after the run with Mimo, it admitted it. It said, I interpreted specialty field as security because previous turns were security reviews, and I pattern matched to the conversation, not my definition. Later on, the build agent, remember this is the one that comes out of the box with OpenCode with all the tools and all the stuff, and it can write code. It actually refused to write the code. It refused to build the software. It said it was a documentation agent and it didn't have the permissions. So what's happening here? Well, after enough back and forth switching in the same thread, the same context, it kind of absorbs the identity from the other agents. So in this case, it absorbed, the documentation agent and started acting like that because it was looking at the conversation context rather than its own definition. Mimo, when I asked about this, even told me that I should have defined agents not only for what they do, but what they don't do. My question is, why didn't Mimo do that since it defined the agents? So I guess there's a bit of a takeaway here. Don't just expect, as I did, to be honest, that Mimo would be best placed to write the agents since it was Mimo using the agents and it knows how it wants to read or look at agents. Read the agent files that you've got and make sure that you're being really specific. Treat it like a dummy. Say, this is what you do, this is what you don't do, this is what you touch, this is what you don't touch. Lessons learned from there, but overall, this was a horrible experiment. Not only was it a lot of effort, but it was a lot of token usage and a lot of time. So on to the fourth approach. This time I learned from my mistakes. I asked Mimo to add instructions for each previous agent, the specialists, and I say, please tell the agents in their definition, not only first thing to read their prompt and prefer this over the context, but also add in the agent's definition, what they don't do. Then I asked Mimo to create a new agent based on this sort of new updated template called the Orchestrator. Now, the orchestrator's job is just to orchestrate other agents towards the goal as we've defined in the specification. Remember that all agents are still in primary mode, but most have explicit instructions in there as how to act as sub-agents. Now, the orchestrator, importantly, doesn't write code. It doesn't do anything. It reads the task. It identifies which agent should handle it. It hands off the context to the agent. It decides, it gets the results, and it routes to the next agent. It checks whether the team is complete before starting, and it also checks whether the team feels like it has reached consensus on the goal before it signals back to me, the human, the task is done. We've built the code. Now, in every run, the orchestrator first noticed that the team had 5 reviewers, but it had no builders. It didn't have a coding agent. So it actually created one on the fly. In fact, quite amusingly, it asked me whether me and the agent, I don't know, it's hard to stop personifying these things, should hire a new developer, which I thought was quite interesting phrasing. And when I said yes, it went and created a developer agent. So that gap detection and that automated creation is actually really genuinely useful. In terms of token usage and things, 8 minutes, 9 minutes, and about 36,000 tokens. So this is much, much better than number 3. Obviously, there is some time and token overhead to this approach, but overall, I would say the benefits of not having to manually call those agents was huge. There's also that smart emergent behavior, like the detection of the skills gaps. But actually in the team, the orchestrator actually did something quite clever. It decided to get the architect involved twice, once before and once after the code creation. And again, that is really useful behavior that I didn't sort of program in. Experiment 5 was almost identical to experiment 4, except that I set all of the agents except the orchestrator and of course the built-in OpenCode default build and plan agents to mode sub-agent. So token usage actually slightly increased, and I did ask Mimo 2.5 why, and it said, well, the platform OpenCode, the harness probably adds system prompts and things for task delegation protocols, result collection, status tracking of the accounts. Because remember, the orchestrator, when it sends another agent, a sub-agent, to do a job, it has to then wait and get a result back and check and all of this stuff. So all of that is adding to the token usage and the wall timing. But I will say, not having to manually do those agent calls is a big, big win. So here's what the full results look like combined. First, the token usage and the wall clock timing. It's true that every layer of coordination, everything you add beyond just the build agent, it does get you something, but it costs you something as well. You know, there's nothing for free. And honestly, for this simple API endpoint and MIMO 2.5 actioning it, I'd probably stick with just the build agent. It's quick, it's reliable. You don't need to define or configure or maintain any of those other agents. Moving to a sub-agent with an orchestrator pattern, it's good. It works very well, and there is that emergent behavior, but you're almost looking at a doubling of token usage and probably 4 to 5 times the amount of time for a benefit that in this simple project I just don't see. Now, yes, I know, you're jumping into the comments already. This might not hold for more complex projects, or the delta might actually get worse with more cross-agent calls and communication. Think about it, if you've got a bigger project, more context sitting in that context window, that buffer, more agents talking back and forth. The model might also make a difference. I'm using MIMO 2.5 here across the board, but we can specify that certain agents have different models. What would happen on DeepSeek v4 or Claude or Qwen or whatever other model that you decide? So this is the point. I encourage you to do your own research and leverage the observability principles that I'm talking about here of token and time tracking to make your own decision based on your project rather than just following some best practice from a blog post or YouTube. With that said, there is a lot to this experiment that I didn't measure. First, quality. I didn't test whether any of these approaches actually produced measurably better code. The orchestrator used 40% more tokens. Did that actually buy anything? Was it worth those 40% tokens? The sub-agent runs, do they have fewer bugs? I don't know that. Scale. I tested with 5 specialists agents on a 3 endpoint API. What happens with 10 specialists? As I say, does the cross communication get better, get worse? What about a real project with lots more code? Does the orchestrator's overhead actually that we're seeing here get dwarfed by the output, by the real work, and therefore make the orchestrator pattern much more valuable? I don't know yet. And as I say, the model, everything here ran on MIMO 2.5. Different models handle context and agents differently. The identity drift problem might be better or worse on other models. The per invocation cost of sub-agents might change with different token pricing. All things that I do need to research and dig into, obviously in future videos that I will share here. So hit subscribe and like. Next time, I'm trying Ponytail. The idea here is think like a senior dev. More what you don't build than what you do build. And I'm wondering, for the same project, for this 3 endpoint API, same model, MIMO 2.5, will it make a difference? Will, or do you really need a more complicated project to really show what Ponytail can do? I don't know. Stay tuned. And on the subject of Ponytail, I do want to say the suggestions from you in the previous video have been fantastic. Ponytail came from the comments. So did Graphify, the Pi coding harness, Light LLM, Lean CTX, Lean Context. Do keep them coming if you find out something, if you've wired something together in a certain way. I'd love to hear about it. As always, hope this was useful. Thanks for tuning in. I'll see you again very soon. Bye.